A tractor climbs at a steady speed of 5 meters per second up a slope inclined at an angle theta to the horizontal. The mass of the tractor is 1400 kg and sine theta equals to 3/25. By modeling the tractor as a particle, find the work done by the tractor against gravity per minute. If the total work done by the tractor in this time is 780 kilojoule, find the resistance to the motion. Okay, first let's sketch. A tractor climbs, so I'm just going to draw a tractor. Okay, somewhat like that. Okay, a tractor, okay, which is climbing at a steady speed, so v equals to 5 meters per second, so it's moving forward. So if that's moving forward, there's always a resistance, okay, that's acting backward. Okay, so r, in this case resistance, is acting opposite direction. Okay, and then let's resolve all the other forces. So we have, oops, so all this is incomplete. So this is sine theta, so I'm just going to write sine theta, or not sine theta, I'll just write it as theta because that's the angle which is unknown, but we know sine theta is given. Okay, so that's that. Now resolving forces, so this is mg sine theta, and we have r, okay, which is the normal force. I'm not sure if we need this, but let's sketch. Okay, whenever you have a question, remember, please sketch so that you can get a picture, at least you know what to do, what are they asking for. And this is w, okay, which is mg. Okay, work done, the total work done by the tractor in this time is 780 kilojoule. Find the resistance to the motion. Okay, first of all, okay, w equals to fd. Okay, let's do this. So f equals to mg sine theta. Okay, f equals to mg sine theta, and then multiply by the distance that it has traveled. Okay, so it's 1400 multiplied by 10 times by sine theta, which is 3/25, and then times by d, the distance. Okay, we have to find what is the distance that it has traveled. If you read the question, it says steady speed 5 meters per second up a slope inclined at an angle, the mass of tractor blah 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 blah, and then find the work done by the tractor against the gravity per minute. Okay, per minute. So the velocity v equals to 5 meters per second, so that's speed. So we know speed equals to distance over time, and time here is given gravity per minute, so it's just for 1 minute, which is 60 seconds, and then speed is 5. So from there we can find what is the distance. So distance equals to 60 times 5, which is 300 meters. Okay, so you can times this by 300 meter over here, and our final answer is so okay, so what I have is, it's 1400, then divide, and then okay, using calculator I've got 1680. Okay, 1680 joule. And since the question requires us to find work done by the tractor against gravity, then we have to use W equals to mgh. Okay, so vertical, what is the vertical work done vertically? So m, in this case we have 1400, and then multiply by 10, multiply by height. What is the height? Okay, so we have to find what's the height over here in this question. So it has moved horizontally around 300 meters. Okay, and which is the hypotenuse of a right angle triangle, and then this is the height, which I'm not sure, but I know this is sine theta equals to 3/25. So we can use trigo to find out what is h. So h here is we can use sine theta equals to h over 300, and sine theta is 3/25 equals to h over 300. So h equals to 300 times by 3 divided by 25, and that's 4 times 3, 12 times 3 is 36. So therefore it's 1400 times 10 times 36, and from there we get 504,000 or 504 kilojoules. So therefore the answer find the work done by the tractor against gravity per minute is 504 kj, okay, kilojoules. Okay, next, for an object or something to move forward on an inclined plane, or a vehicle to move on an inclined plane, okay, the force that's acting forward is called driving force. Okay, driving force. So this driving force is basically culmination or the combination of two of the other forces. Okay, so if I want to find the net force, so the driving force will be mg sine theta and plus the resistance. Okay, if it's if it's in equilibrium, then mg sine theta plus the resistance will be the driving force. Okay, so in this question, okay, work done, okay, horizontally, work done, I need to consider the driving force, okay, and then multiply by the distance traveled. We already know what is the distance traveled, but what is the driving force? Driving force is basically what's forward is equal to what's at the back. Okay, so these two, mg sine theta plus the resistance, they are the driving force. Okay, this is what the driving force. So we assume that it is same, okay, in equilibrium. Even if it's not, then we have an acceleration, okay, when it moves forward. Okay, that'll be the net force. We are not worried about the net force. I just want to know what's the driving force. Okay, so the basically driving force is same as the mg sine theta plus the resistance, and then multiply by the distance traveled. In this case is 300. So work done, okay, your final work done, from the question it's given that work done, the total work done by the tractor is 780. So 780,000, and this is what the work done from the driving force. So if I want to find what is the resistance, m and g is given. M is 1400, and then g is 10, and then sine theta is 3/25. So you have to add that 3/25, and then plus r times 300. Okay, so going with this, so I have 1400 times 10 times 3/25, which we already got it over here, 1680. So 1680 multiplied by 1680 plus r multiplied by 300, and the answer is 780,000. So therefore, if I want to find what is the resistance, so 780,000 you divide by 300. Okay, so That's 7800 divided by 300, 1680 plus R, and then 7800 over 300 minus 1680 equals to R. So from here R equals to 7800 to 7800 divided by 3 and then minus 1680, and the answer is 920 Newton, and that is the resistance. Okay.